Hello friends, in the last video we discussed about series connection of RLC elements. In this video we are going to discuss about parallel connection of RLC elements in a circuit. Let's see the definition of parallel connection. One end of the all elements are connected to one point and other end of all elements are connected to another point is called parallel connection. Okay? One end of all elements are connected to one point and other end of all elements are connected to another point is called parallel connection. In parallel connection, voltage is same but current is different. It's shown here. In parallel connection, voltage is same but current is different. Let's see this example. Here two resistors are connected in parallel. How I can say these two resistors are connected in parallel means the first end of the two resistors are connected at one point. See here, this is the first end of the second resistor and this is the first end of the first resistor, or those two are connected in one point, and second end of the first resistor and second end of the second resistor are connected in one point. This connection is nothing but parallel connection. Okay, according to parallel connection, in parallel connection voltage is same but current is different. Here I apply a voltage source V. Due to this voltage source, current produced in the circuit is I. In this branch current is I. Here parallel connection of R1 and R2 is there. Whenever a parallel connection is there, then our current is divided into two parts according to KCL. Okay, this current I is divided into I1 plus I2. This I1 and I2 currents are based on the resistances. These R1 and R2. Whenever we get this type of connection in circuit, then we can simplify the instead of two resistors into one resistor by using this formula. Req, eq means equivalent, equal to R1 into R2 by R1 plus R2, where R1 and R2 are the resistances of first resistor and second resistor. Okay, that means we can represent these two resistors into one resistor by using this formula, R1 into R2 by R1 plus R2. Let's see the another example. Consider inductors are connected in parallel. Okay, inductors are connected in parallel, like resistors are like resistors. Here also current is divided into two parts. Okay, and instead of these two inductors we can represent into a single inductor, Leq. Eq means equivalent, by using this formula, L1 into L2 by L1 plus L2, where L1 and L2 are the inductances of first inductor and second inductor. And consider capacitors are connected in parallel. This is somewhat different from these two resistors and inductors. Capacitors are somewhat different. Let's see. Here two capacitors are connected in parallel. Whenever two capacitors are connected in parallel, we can simplify it to a one resistor by using this formula, C1 plus C2, where C1 is the first capacitance and C2 is the second capacitance. Okay, we simply add two capacitance values and represent into a one capacitor. This is about parallel connection. In next class we will go to discuss about what is delta connection and what is star connection of resistors. Okay, thank you.